Kenny interviewed freshmen and seniors at his high school, asking them how many pieces of fruit they eat each day. The results are shown in the two plots below. And so the first statement that we have to complete is the mean number of fruits is greater for, and let me go to the actual screen, is greater for, and we have to pick between freshmen and seniors. And then they say the mean is a good measure for the center of distribution of, and we pick either freshmen or seniors. So let me go back to my scratch pad here, and let's think about this. So let's first think about the first part. So let's just calculate the mean for each of these distributions. And I encourage you to pause the video and try to calculate it out on your own. So let's first think about the mean number of fruit for freshmen. So essentially, we're just going to take each of these data points, add them all together, and then divide by the number of data points that we have. So we have one data point at 0. So we have one data point at 0. So I'll write 0. And then we have two data points at 1. So we could say plus 2 times 1. And then we have two data points at 2. So we can write plus 2 times 2. And then let's see, we have a bunch of data. We have 4 data points at 3s, or you could say we have 4 3s. So let me circle that. So we have 4 3s plus 4 times 3. And then we have 3 4s, so plus 3 times 4. And then we have a 5, so plus 5. And then we have a 6. Let me do this in a color that you can see. And then we have a 6 right over here, plus 6. And how many total points did we have? Well, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, actually, be careful. We had 15 points, and I didn't put that one in there. So actually, let me just... So we have 15 points, and I can't forget this one over here. So plus... My pen is acting a little funny right now, but we'll power through that. Plus 19. Plus 19. So what is this going to be? So this is just going to be 0. This is going to be 2. This is going to be 4. This is going to be 12. My pen is really acting up. It's almost like it's running out of digital ink or something. And this is going to be another 12. And then we have 5, 6, and 19. So what is this going to be? 2 plus 4 is 6. Plus 24 is 30, plus 11 is 41, plus 19 gets us to 60. 60 divided by 15 is 4. So the mean number of fruit per day for the freshman is 4 pieces of fruit per day. So this right over here, that right over there is our mean for the, let me put that in a color that you can actually see. Now let's do the same calculation for the seniors. So we have one data point where they didn't eat any fruit at all each day, not too healthy. Then you have 1, 1. So I'll just write that as, I could write that as 1 times 1, but I'll just write that as 1. Then we have 2 2s. So plus 2 times 2. And then we have 1, 2, 3, 4, 5 3s. 5 3s. So plus 5 times 3. And then we have 3 4s, so plus 3 times 4. And then we have 2 5s, plus 2 times 5. And then we have a 6. We have a 6 plus 6. And we have a 7. Someone eats 7 pieces of fruit each day. A lot of fiber. Plus 7. And now, how many data points did we have? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 data points. So we're going to divide this by 16. So what is this going to be? This is just 0. Let's see. This is just right over. That's 0. This is 4. This is 15. This is 12. And this is 10. So we have 1 plus 4 is 5. Plus 15 is 20, plus 12 is 32, plus 10 is 42, 42 plus 6 is 48, 48, am I doing 42 plus 6 is 48, plus 7, 48 plus 7 is 55. Did I do that right? Let me do that one more time. 1 plus 4 is 5, plus 15 is 20. 32, 42. 42 plus 13 is 55. So this is equal to 55 over 16, which is the same thing as, let's see, that's the same thing as 3. And 3 times 16 is 48. So 3 and 7 sixteenths. So the mean for the seniors, 3 and 7 sixteenths, is right around, let's see, this is 3, that's 4, so 7 sixteenths, it's a little less than a half. It's right around there. So the mean number of fruits is definitely greater for the freshmen. They have 4. Their mean number of fruit eaten per day is 4 versus 3 and 7 sixteenths. The mean is a good measure for the center of the distribution of. So when we think about whether it's freshmen or seniors, so the mean is fairly sensitive to when you have outliers here. For example, someone here was eating 19 pieces of fruit per day. That's an enormous amount of fruit. They must be only eating fruit. You can imagine if it was even a bigger outlier, if someone was eating 20 or 30 pieces of fruit, just that one data point will skew the entire mean upwards. That wouldn't be the effect on the mode, because the mode is the middle number. Even if you change this 1 point all the way out here, it's not going to change what the middle number is. So the mean is more sensitive to these outliers, to these points that are really high, really low. So, and because the seniors don't seem to have any outliers like that, I would say that the mean is a good measure for the center of distribution for the seniors, or a better measure for the center of distribution for the seniors. So let's fill both of those out. So the mean number of fruit is greater for the freshmen, and the mean is a good measure for the center of distribution for the seniors. And you actually even see it here. We saw that the mean number for freshmen was at 4. But if you just ignored this person right over here, and just you kind of thought about the bulk of this distribution right over here, 4 really doesn't look like the center of it. The center of it looks closer to 3 here. And what happened is this one person eating 19 pieces of fruit per day skewed the mean upwards. While here, that 3 and 7 sixteenths really did look closer to the actual distribution, closer to the, actually I shouldn't say, in both times we actually did calculate the mean of the actual distribution. But here, since there's no outliers, it does seem, the mean seemed much closer to, I guess you could say, the middle of this pile right over here. So let's check our answer, and we got it right.